Hello, good afternoon, young people. This is the May-June paper 2020. And of course, with paper two, we have been through a couple paper twos and they get the gist or the feel of this, yeah? So let's just jump straight into it so we can knock it off well within the 2 hours. I wonder if we can get it done in 1 hour. Let's see, give it a try. All right, so question number one. Direct data entry devices that transfer data directly from a document into a computer system. Circle the two direct data entry devices from the following list of input devices. Barcode reader. Yes, we know barcode readers. You scan the barcode, normally the item at a point of sale or so at a supermarket, clothing store, any store. Or sometimes even places of, let's say, a receptionist, depending on the barcode on your wrist by the band they strap on you when you're at a hotel or a villa. All right. Joystick, used to little lever-like thing, just to play games and so on sometimes. Light pen, stylus-looking thing, sometimes wired, connected to a computer device or so, or a little trackpad thing to trace on. Touch screen, we know touch screens are. We see them at fast food places all the time, and even the very devices that we have in our hands, like tablets and phones and so on. Some laptops as well. Optical mark reader, we know we use to mark multiple choice papers, depending on what you shaded. So which two do you think are most likely? I would suggest barcode readers and optical mark readers are the answers to this question. All right. Name an application in which any one of the devices circled in 1A is used and describe the type of data that is captured with that device. As I spoke about barcode readers at a point of sale, whether a clothing store, supermarket, or so on, sometimes even at appliance stores and so on, barcode readers, yes. Pick up the type of items, the size, the color, what else? Anything else that applies to the product that was initially scanned in, because the computer does not automatically know by the barcode, right? What it does is that what the merchant would have done is to scan the item when it's coming into the store. They would have entered the different details like what type of product is that shoes, pants, hat, bag, what size, what color, also on applicable, and the price. All of those things. Even if there's a discount that may apply to the item. All right. Optical mark readers, think of your multiple choice questions that you're going to be shading in soon, maybe on the same day in the afternoon of this exam. Sometimes for surveys as well. All right, and other documents. All right. So those are different applications that can be used for. All right. Part B. Turnaround documents are popular with automated methods of data entry. Describe what is meant by a turnaround document. A turnaround document really is a document that is initially prepared, normally by a computer printout, like a multiple choice paper, but then you make certain responses and it goes back to the source or a third party. So initially prepared by a computer device, and then you would fill out certain data or shade or so forth, and then it goes back to whichever source that the sender initially asked you to send it to, or back to the same source. Explain how data is captured from a turnaround document. It's captured usually by an OMR, as spoken of up here. Scanned, as I say, shading in, surveys, etc. Right? Scan. Passing light through the document. It reads the part that are shaded or the answers that are there. Sometimes there are OCR, optical character readers, right? That can actually read the symbols, the signs, and convert it based upon the marking to text. That's also applicable. All right, question C, same answer, same question. Question number 1. Determine the number of 5 megabyte documents that could fit in a 16 gigabyte flash drive. Yes, did this one the other day. All right. Let me see now. Oh, we're not allowed to use multiple choice, are we? In IT exam. Last time I checked, I don't think we were. So let's do this the old-fashioned way, yeah? Let's use our paper. All right, let's map this out now. So let's use what we know math to be when we can use some cancellation principles. So let me see again. What was again? What size was this document? 16 gig. All right. So 16 gigs. So 16, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 16 billion. All right. And put another 0 here so we know what we're dealing with. 1, 2, 3. So 16 billion. That's what 16 gigs is all about, right? And we are trying to ascertain now 5 gigabytes. So 5 gigabyte really is 5 million. All right, so it's 5, 1, 2, 3, 1, 2, 3. All right, put the commas in so we can work the process of cancellation, right? Oops, comma. So here's what we can do. We can cancel these 6 zeros here. Where's the strike through option again? Here it is. There's a strike through option here. Where is it again? I don't even see it. Here it is. Yeah, here. Strike through. 6 zeros there. And then we strike through these 6 zeros here. All right, then now. So now we need to find out how many times can 5 go into 16,000. All right. So here's what we do now. All right. 5 can go into 16 into 6 0 times. Let me get rid of the strike through option. It can go into 16 into 1 0 times, into 16 3 times with a remainder of 1 here. All right. So let us say I have a remainder of 1. So how much then can 5 go into 10 here? It would be 2 times, right? 2 times. So 5 into 10. Remember this 1 here, so like I had the 1 from 5 into 16, 3 times, remainder 1. And then it would go on to saying, okay, then 5 into 3, 16 times. So 5 into 16, 3 times, remainder 1. Then 5 into, this would have been 10, carry 1 over, which would be 2. And then we have 2 more zeros, so it's 0, 0. So it's 3,200 times. That will be our answer. Rushed with this the other day. I made a mockery of myself, but so it is. All right. But let's continue checking as fast as we can go. Done with that question. And it's only for 2 marks. Really? All right. Consider the following paragraph. A printer is an output device on a computer system used to print hard copy output. Printers fall into 2 categories, impact and non-impact. Non-impact printers spray ink or toner powder on the characters, and the characters are fixed to the paper by heating. Examples of non-impact printers are inkjet printers, laser printers, and thermal printers. True. Impact printers strike the paper when printing. The most popular impact printer is a dot matrix printer. Dot matrix printers print multiple copies using carbon paper. Also true. All right. So they give us a paragraph here of true statements. Let's see what happens here. State the steps in the correct order required to find the number of words in the paragraph above using a word processing system. You could highlight it. Let's say Microsoft Word here. You could say this is a test to determine number of words. All right. Right here, we see here that we can highlight it. And at the bottom here, it says 9 of 12 words. So we have these 3, 1, 2, 3 being picked up as words. See, 9 of 12. We can also right click, and we should have an option that talks about word count. Let me see now, paragraph. Sometimes I have an option that suggests word count. Paragraph, no. There's an option there that sometimes suggests word count, but usually we see it here. And to prove this, we can delete these 2, and we will see that we have 9 of 9 words down here. So right click, highlight it, right click, and So I right click and go to the status bar down here to the number of words. But there's usually an option that says word count. Alright? But let's move on. Anyway, trying to get this paper done in 1 hour. Trying to prove a point here and see how well this works. Until we get to programming, and it will take a little bit more time. Listing the steps in correct order required. List the steps in the correct order required to conduct a spell check of the paragraph above using a word processing program. You can highlight it, as I did before, right click, and then we could go, if there's a word misspelled, let me see, you can point on the word, to the red line there, point on the word, right click, and you choose from the list that's here. Another option is that we could highlight a section, and then we could click the spelling option here, right? See, the ABC, sometimes that's another option, and the options would come up on the right hand pane over here. Another option we could do is we could go to, wait again, which one are these options again? Not design, view, and we should have spell check somewhere in one of these options here. Again, view, review, sorry, review, and you have spelling and grammar. You could select that, not view but review, and you have spelling and grammar. Click on that, and then you select the word as is best selected, right? So those are 3 ways we could use spell check. All right, but let's continue. Just select whichever one that suits you, and then in the correct order, and 3 marks. All right. Part E. The following diagram illustrates the dialog box obtained when using the find and replace editing software in a word processing program. To replace all 5 occurrences of the word print, find the word with the word produce in the paragraph in D on page 5. All right. How would we do this? Find and replace is rather easy to use. Make sure you're at the home tab, I believe, and then you go over here and select find and replace. What you then do is click on the option, hold on, sorry, click replace, sorry, and then what you then do, find what? Let's say we want to find this, let us say of, and I want to replace it with. All right, then we click replace. I will see the word of is highlighted. I will select replace and then click OK. And then let's close this now. We notice that the word of is now replaced with. All right, that's a simple example, rudimentary example. All right, so that's how we go about doing that. Explain. So that's for some persons who don't know how to use find and replace, that's how it's done. Briefly explain why it would be safer to use find and replace option than replace all option in the dialog box above. The replace option as opposed to replace all. Because sometimes you may end up replacing other words that you don't want to select. All right? You might not want to replace every single occurrence. Let me give you an example where this is not a good idea. Let's talk about the word print. Let's say words printed by a printer with which we want, these are occurrences here, which we want to print. All right, now here's what happened with find and replace. We click replace, yeah? Now if I want to find the word print, and I want to place it with, let us say, show, or let's say hard copy. All right, let's use just one word, right? Hard copy. That's like hard copy. All right. If I click replace all, notice what happens here. Every single one of them was replaced. Print, printed, printer, hard copier, and this was printed. Let me undo this. Undo. You see? printed. So it will replace even words which have the word print in it. That is the problem with replace all. So the best thing to do is go to replace, but use one at a time. For example, let's say we want to skip that. So let's just say, for example, find next. Oh, this one is fine. I want to replace that one. Then we click replace. No, we're done. Because if you click replace all, it will replace even words that have the word printed in it. Would not be a good idea. Because then you have hard copied, hard copier, and so it just wouldn't work. All right, not a good idea. All right, let us continue. Time is ticking. All right. Sharon recently had a home network built with both wired and wireless capability to facilitate a new home-based business initiative. State the location of the network where each of the following hardware devices could be found and describe the function of each device. Network interface card. And nick a network interface card, rather than just telling you what it is, let us use faithful old Google and let me show you. Let me see what you'd come up with first. Image of a network interface, interface card. Now here it is. Here's an example of one. When you look at these, where do these look like they would be? Right? Where does it look like you'd be? These kind of cards. They would be, of course, inside the system unit. All right? The location will be inside the system unit. And you plug it at the back, just like how, and these are normally desktop systems, right? Smaller ones could be inside laptops, yes, but mainly you look for the ones that we showed a while ago in a system unit, right? The function is to help you to connect to a network, wireless or through the Cat5 cable, RJ45 or Cat5. RJ45 Ethernet, yeah. Cat5, Ethernet, RJ45 cable. Any one of those. So the same blue cables we call network cables, yes. That is what you do. Connect to a network, including the internet as well is a part of a network, is also a network, right? What you find is that you connect to a network, internet or a local area network or something like that with a cable or wirelessly, all right? Wireless network adapter, location, whoa, that's what I said, in a room, in the building, somewhere in the building, ceiling or desk or so forth. Let's show that image of this. This could be anywhere, on a desk, on a ceiling, on a wall, anywhere, right? Wireless access point. Same thing as what they're talking about here, yeah? And of course, it's them, you know, stuff like these. Hold on, let me not do that. Let's go straight to images so we can see it better. So here are some of these. So I'm sure you see some of these at home. You see on the wall, it can be on a desk. It can be in the ceiling. It can be anywhere. But usually you put it at a point that's fairly high to feed the signal throughout the home. Yeah? All right. So location on a wall, in the ceiling, on a desk. Function to allow various devices, not just phones and tablets and laptops and desktop computers as well, but also printers to a network so you can print wirelessly. All right. A modem. The show putting us to the ringer with this man. A modem normally would be on the desk. Modem on the desk. Function to allow you to transmit signals over a telephone network. A network with RJ11, I think that's RJ11 wires, old telephone wires. Yeah? Where modems come from the word modulation. So this part here of modem, mod, comes from the word modulation, which means to convert digital signals to analog, right? And then still using the D again, although we have one D, says demodulator is where it converts the analog signal back to digital so the computer can understand and process it, right? So that's what a modem really is. And you can have it on your desk, location on the desk, on a wall, it can be on a shelf, stuff like that. And of course, modems normally indicate a wired connection. Use a cable. And the function is to get you to transmit signals over a network, normal telephone network, RJ11 jack, which is analog. All right. Router, last one. Router is strictly digital. Some like a modem, but it transmits purely digital signals. Let me show you what a router look like again, since we have faithful Google here. Image of a router. And now, guys, you might be confused a little bit because routers may look similar. Routers, all right, they look similar, right? And why is because there is a blurring of the lines now between routers and modems and so on. They cannot have the devices doing multiple functions, right? But modem converts analog signal converts digital signal to analog. That's what we call modulation. Then at the receiving end from the other computer, it converts the analog signal it picked up from the lines, telephone lines over the streets and on the highways or wherever it's coming from, back to digital so the computer can understand it. That's demodulation. That's the primary purpose of a modem. However, what you find now is that we have routers, which do a similar thing, but routers deal with digital signals and would transmit the data to specific computers along the network, right? As opposed to what a switch would do and so forth. Don't want to get into that because we weren't asked about switches, all right? As we continue, part B of the same questions, and time is running, all right. The wireless devices are accessing the internet, but Sharon's desktop computer was unable to access the internet. So there's two instructions that could be given to Sharon to help her to troubleshoot the problem. Well, two instructions could be maybe she have airplane mode on, maybe her wireless port is off on her laptop or her device. If it's off, you just switch it on. It could also be that the drivers are missing. Remember, drivers are small software that tell a computer how to manage or operate a certain hardware device. Those are three. She probably would need to check firewalls, go into deeper stuff, making sure her firewall is allowing her browser to connect. That's 4. What else could she do? Making sure she's not too far from the signal either. Because if the signal are there are no barriers between where she is, because some routers kind of weak. If you're too far away, even though it could be just what appears to be a few feet. If there are walls in between and so forth, could also be interference. If you have a microwave on, like simply a microwave oven or some speakers and so on, and they're not magnetically shielded, those are things that can affect your wireless signal. Too much interference, all right, in the environment. All right, okay, I give you about 5. All right, you can look into any one of them to get some deeper understanding. All right, part C, the same question. Examine the following chart created from data in a spreadsheet. All right, so it's called book sales for week 2. And it's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. All right. As this book sales, we assume that these are dollar amounts. So from $0 to $100 to $200, $300, $400, $500. All right. And whoa, the shading here looks kind of weird. I wonder if we can make this out. Oh, they don't ask us anything like this, you know. Novels, magazines, textbooks, cookbooks, comics, total. So the big stacks here are totals. List the steps in the correct order required to create the chart from data in a spreadsheet. First of all, you want to highlight all the data, including the labels at the top and the side. All right, so the words, right? Highlight all the data. Then go to Insert, select Chart. And in this case, you can select Column Chart. Then select the type of column chart that you want. Then as soon as you click on it, it will put a chart on your spreadsheet. Then what you could do is to go in and go to insert chart elements. Let me go back here. Chart elements. Depending on the version of Microsoft Office that you're using, you might need to listen now. I want a chart here. Let's see. Let me see this. Can I use this? Yeah. Let me see now. Let's say I select this data. I want a chart. All right. So I highlight the words as well, and just the data points. All right. Words and the numbers. I go to insert, and then I select column chart. And let's say I select this one, type of column chart, and then I can go add chart element here to insert the axis labels without y-axis or x-axis or y-axis or so forth. All right, because so select whichever one of them. The vertical will be the y and the horizontal the x-axis. And then I could insert the chart title as well. All right, or I can simply double click here and type in the chart title that I want. All right, let's call this nada. All right, so that is how we could create a chart. Close this, and I'm not going to save it. All right, so that's how we create a chart, a column chart, 4 marks. Took too long with that. State one other type of chart that is appropriate to represent the data in the spreadsheet and state how it differs from the one on page 8. Another chart that could be used is a line chart. A line chart because it has to do with time. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. A time chart is best used to indicate progress or regression over time. So you can see whether you're growing or basically regressing. All right. Name one type of chart other than those mentioned in 1 and 2 and describe when it is best used. One other type of chart is to describe it. Now, that's whether it's an appropriate chart. But one other type of chart, let us say a column chart. A column chart could be used to best represent elements, just as how this one would. This one's a column bar chart. Sorry. Could be used to represent data just as much as this one would. Just that the data will be going across. The columns will be going across rather than stacking up from bottom to top or top to bottom. Rather than stacks going up, they'll be going across this way. All right, we're going across. All right, from left to right. You could also have a pie chart. So, but a pie chart would be suitable for this though. When a pie chart is used to display proportions of a whole, right? Of a whole. So a pie chart would be best used to represent this because you're representing Monday, Tuesday, Wednesday, Thursday, and Friday. Plus, on top of that, using novels, magazine, textbooks, cookbooks, comics, total. A pie chart could only represent either the days or the types of books or the totals. Could not represent so many different things, right? Pie chart would be best suited for that. All right. Then next up we have how much marks for that? 2 marks, really? All right. Then now we have part 4. And Sharon used the following spreadsheet to create the chart displayed on page 8. Write the formula or function to be inserted in cell B8. B8 is here. To calculate the total number of books sold on Monday. So that chart, that would be total books sold equal formula or function. So the function would be equal sum, open brackets, that appears to be B3 colon B7, close brackets. Let me check and make sure that those cell addresses are correct. B3 to B7, right. That is the function. The formula would be equal B3 plus B4 plus B5 plus B6 plus B7. So that's the corresponding formula to represent this function. All right, next up. All right, next up. Question number 3. Whoa, there's about half an hour now. We're going well, man. But we know we have to write some code here. In this question or question 4. So that's going to slow us down a bit. All right, complete the table below by inserting the most appropriate web technology concepts from the following list. Yippee! All right, now let's get to work. Connects web pages to other web pages. Hyperlink. Here it is, hyperlink, yeah? connect web pages to different web pages, or even another part of the same web page, even another website. So those are hyperlinks. Stores, process, and delivers web pages to client devices on request. All right, web browser, hypertext markup language, file transfer protocol, uniform resource locator. Let's hold on this one a little bit and see. Come back here. Facilitates communication with client devices for the delivery of web pages. All right, hypertext transfer protocol. All right, that's what that is, right? Facilitates communication with client devices for delivery of web pages. Hypertext transfer protocol. Sure about that one, right? Software application that allows client devices to access resources and websites on the internet. Web browser. Web-based application used to create web pages for display of the display on client devices. Hypertext markup language. All right. Let's get back to this now. Stores, processes, and delivers web pages to client devices. That not uniform, not URL. Uniform is hypertext. We did it already. File transfer protocol. Web server. Yeah, didn't say that one. Web server. Stores, processes, and delivers web pages to client devices on request. Web server. Never said that one. So that ends our 5-mark quest. Done. We move on. All right. Next. Wow. I can barely make this out. All right. Consider the following database with two database tables. Consider the following database with two database tables: name, students, and sports. Whoa. I really hope you guys can see this because this looks really messy. All right. Anyway, let's continue. Database table students and sports can be joined in a one-to-many relationship to ensure that data in the two tables remain as accurate as possible. State the feature that is used to establish and maintain the accuracy of data between two database tables. State the feature. It's called a database relationship. State the feature that is used to establish and maintain accuracy of data between the two database tables. I'm thinking a database relationship. I want to make sure, because that kind of have a little way. Sport it would not be primary keys, would it? It says, state the feature that is used to establish and maintain accuracy of data between two database tables. I'm thinking relationships, but even to be more detailed, the part that says enforce referential integrity. I'm thinking that is the best answer. All right? Database relationships enforcing referential integrity. All right? State why it is necessary to maintain the accuracy of data between the two database tables. It's important because you may end up corrupting the data. You don't want that to happen. All right? Create a query by completing the following query design view window to extract. Okay. Extract the fields ID, first name, last name, phone from the students table. In the sport field, sports table for married students who play football. So go up to this now. Married students, yes or no? So under this criteria, in the criteria row here under married, I'd put yes. And the sport would be, let me show, sport name, football, right? So under sport name, I'd put in football in the criteria row. So yes under married and football under sport name in the same criteria row. All right, cool. State the record IDs of the records that will be extracted when the query designed in C is executed. So looking for all married, let me say football is 020. So married, so that will be Brian Joseph, married, yes, 020. And 020 again, Smith Jones, married, yes, Just Jones Smith and Brian Joseph. Let me see if I know 020. Yes, no, no. 020. No, this person isn't married, so that wouldn't work. So these two persons, Smith, let me see, this is Brian, whatever Joseph this is, right? Joseph 020 and he's married, right? Next 020 is Smith Jones, married, and so on. Male gender. So the two males are selected there. That would work. All right. There are 4 steps in implementing a program. List 3 of these steps. All right. There are 4 steps in implementing a program. 1, you want to link it. You also want to execute, compile, maintain. Those are the steps you're talking about. All right. In implementing a program. All right. Part 2, describe what is involved in any 2 of the steps listed in A. All right. So when you compile, it means that you're actually executing the program. That's one. You're compiling a program, executing it, getting the program to work. Maintaining simply means that you want to make sure it keeps working, but also to improve on it. Linking, because sometimes you might have, oh boy. I want to keep it at those 2 because linking between different classes or objects or so on to incorporate other classes or objects and libraries into your program. I don't want to go that deep because I did not teach that to my students and many teachers don't. Talk about linking. All right. Documenting also is another one. You want to write instructions to how the program works. So other persons who are following after maybe you have retired, after you have resigned, hopefully not fallen ill or worse, but other programmers come on the scene, and also for your own self, because you have written a lot of programs and maybe you don't even remember exactly what this one is doing. So it also helps you as a record. All right. What else? Okay, F. Making good time. Whoa. Complete the following pseudocode by writing a nested if-then-else statement to produce the following. If team A scores more goals than B, the algorithm should print team A is the winner. If team B scores more goals than A, then the algorithm would output team B is the winner. Otherwise, the program should output game drawn. All right? So they give us a part of the program, and we should continue it. Now, let us work this out. All right. And let me write exactly what they're writing here. So, write enter, then we'll go to team A, team B, that. Okay. So say if team underscore A, hold on a sec. Hold on. Let me read this program carefully. I'll just jump into. All right. Enter the name and number of goals by team A. Goals. Okay, sorry. Let me go back up. So I sleep a little better now so I can see exactly what I'm doing because that felt like an error a while ago. So if goals underscore A is greater than goals underscore B, then let me tab print team A is the winner, and that's it. Else if goals underscore B is greater than goals underscore A, then I'd say print team B is the winner. And then I'd say else print, let's say game is drawn, Game is drawn. And then I say end if. And that ends my little program there. So that ends, I want to give you a whole marks for this, you know. Right? 5 marks. All right, no problem. But what we do is put this on it. Why? Because apparently, based upon the instructions given, guys, listen, based upon the instructions given, we noticed that they said here, enter the name and number of goals scored by Team A. They say read Team A, that would be the name, and goals A. So the goals related to Team A. Same thing for Team B. Write the name and enter number of goals scored by Team B. So it would read the name of Team B and goals by B, right? So then now would compare, since goals A and goals B actually would have the amount of goals scored, we would then compare goals A to goals B. If that is greater, if goals A number of goals is greater than goals for B, right, then we know Team A won. Else, if goals B, as in the number of goals scored for Team B, is greater than the number of goals scored for Team A, in the variable goals A, then print Team B is the winner. But if none of them are greater, then we know that it must be that they are equal. Because if A is not greater than B and B is not greater than A, the only other option is the numbers are equal. Hence, we have else, print game is drawn. And else, as we already know, else must mean the last option available. All right? Cool. Now let's get going again. 5 marks and we run along. Question 4. We're really going to knock the paper in 1 hour, guys, hopefully. All right? Hopefully there are no glitches with any long questions. All right? A credit union gives loans of 10,000 at a fixed... we're going to have to code for this. All right? A credit union gives loans of $10,000 at a fixed monthly interest rate of 1% on the principal a month. The monthly payment is a fixed $1,000. All right? The amount paid to the principal each month is a monthly payment minus the interest paid for the month. Okay? The pseudocode below will print a payment schedule showing the principal, the payment made to the principal, and the interest charged for each month when the principal is greater than 0. The payment schedule will also print the total amount to the principal, the total amount of interest paid, and the number of payments made. I don't even remember all of what I just read. But let's get into this, right? So set principal to 10,000, set monthly payment to 1,000. Set monthly interest at 0.01. All right, cool, fine. That is indeed sound like 10%, right? Make sure. Oh, sorry, 1%. 1%. 1 will be here, that's 100%, then 10, then 1. Cool, all right. Making sure, no. Cool. Write the principal, display on the screen, principal, comma, payment, comma, interest. While principal is greater than 0, do set interest to that. Set payment, hold on. Let me see what I ask it. Identify 2 variables which when added will always be equal to the repayment amount of 1,000. Identify the 2 variables which when added will always be equal to the monthly repayment. Okay, that's interesting way of putting it. Monthly payment would always be equal to 1,000, the $1,000, and that's the monthly payment. And let me see now. Principal times monthly interest, no. Let me see now. Total interest, Total payment plus payment. I see what they're saying here. Set new principal to principal minus payment. The principal times monthly interest. The principal times monthly interest, and that would be because 1% of 10,000 is not 1,000. Set payment, monthly payment minus interest. The interest, monthly payment minus interest. That total payment. This wouldn't be it either. I'm overlooking something here. The new principal, total payment, total interest count. I'll read through that too fast. The monthly payment is a fixed amount, right? Okay. Identify two variables which when added will always be equal to the monthly repayment of $1,000. 10,000. Set monthly payment to 1,000. Monthly payment is 1,000. All right. Monthly interest. Right. Set interest. Let me see what question I must be getting for this question. Part B says the pseudocode has a logic error. Identify the line with the logic error and make the necessary corrections. Yeah, man. Set principal to 10,000. True. Set monthly payment to 1,000. Fine. Set monthly interest to 0.01. Write the principal. Okay, write all of those. List them in a column. All right. Set interest to principal times monthly interest. Hold on, let me see. They couldn't give fixed monthly interest of 1%. Okay. So the interest is principal times monthly interest. Okay. However, do you know? I'm looking at there's a competition here that is playing with me a little bit. 10,000 multiplied by 0.01, exactly 100, right? And monthly payment interest, set payment to monthly payment minus interest. Which interest? The monthly interest. Set payment to monthly payment minus interest. Set total interest to total interest plus interest. Total interest plus interest. Fine, that's fine. Total payment plus payment, that is also fine. All right. Somehow this line 7 here, let me look at the rest of the code. All right, set new principal to principal minus payment, counter end while, right, total payment, total interest, and count. I have to go read over this and find out exactly. We should get a good handle as to what exactly they're asking us to do. We have 20 more minutes before the 1 hour up. Let me see what else I have left to do. I'll go and come back to this question. So I spend some time and go through it properly. That's what I want to do. Spend some time and read through it properly. That's quite a bit of data. Identify the stage in the program implementation, the type of error stated. I have to go find the error. State the type of looping construct used in the pseudocode, do while. That's the type of looping construct used. Alright. State one reason why the looping construct in C is used in the pseudocode. Because it repeats as long as the condition is true. And while it's not equal to, while the principal is greater than 0, you want it to calculate the interest and the payments. Alright, that means there's a loan still there. Alright. Explain one other named looping construct that could be used in the program. Repeat until. Alright. Complete the following trace table by inserting the missing values for the variable in each row representing the first 3 times the pseudocode loops. Alright, go and come to that back to that as well. Let me just get rid of the rest of these questions and come back to this part. But this program going to require a little bit of thinking. We'll come back to that. It should be fairly simple to map through, but I've been trying to get this challenge myself to get this paper done in 1 hour, and it looks like I'm going to spend a little over an hour because now I have about 10 more minutes left. Let's get this done, right? The advent of COVID-19 pandemic has resulted in an increase in connectivity and online activities. For example, telecommuting, cybercriminal activities, and greater use of cloud-based applications. Describe the concept of telecommuting and state one reason why telecommuting is so impactful. Well, telecommuting really is working from home. And it's so impactful because companies were able to allow persons to work from home rather than being in a closed environment, which would have enhanced the spread of COVID-19, contractions of the disease. That's basically it. Enhance the spread of the disease. Describe the concept of telecommuting, working from home via a network, via computers and network, right? Describe the term denial of service attack, giving one example. Denial of service simply means when you try to access a web server or a server, it tells you that you can't connect to the server. And the whole idea about it is that they are trying to prevent persons from being productive. Remember, the whole idea of criminals and hackers is to disrupt, persons' basic productivity, right? That's what a denial of service attack is. So we can go and we can Google it if you wish, for persons who know. If it's comfortable, denial of service. Denial of service attacks. Here it is. Denial of service attack is an attack meant to shut down a machine or network, making it inaccessible to intended users. Denial of service attacks accomplish that by flooding the internet with traffic or by sending it information that triggers a crash. See? Yeah. So you basically make the server basically almost inoperable, or in terms of persons can't get to connect to the server. Alright, that's basically what it does. State one similarity and one difference between Bluetooth and Wi-Fi technologies. Okay, both are wireless. Wi-Fi allow a greater distance. You can connect over a greater distance and even through a wall. You might be the opposite. One person might be at one part of the wall in terms of behind the wall, you're the other end of the wall or other part of the wall. We can connect through the wall. As opposed to, that's Wi-Fi. As opposed to Bluetooth. Bluetooth doesn't really allow that. And you normally have to be in a few feet apart. Not, let's say for example, 20, 30 feet like what Wi-Fi would allow. State two advantages and one advantage of buying software application stored on the cloud. One advantage is you have access to it no matter where you are in the world. 3, that's one advantage. One disadvantage is you have to be connected to the internet to get access to it. Alright, that is one disadvantage. Now let's go back to this troublesome question. Let me spend some time and read it through. And now, matter of fact, let's do this trace table. This trace table will help us find what the problem is. Alright, so almost 1 hour. almost 1 hour. All right. I like to use spreadsheet and do trace tables. Give me flexibility of calculations. All right. All right. Principal and payment. Monthly interest. All right. But this will be smaller. And grid this up. All right. All right, let's get going on this thing. All right. So start off with $10,000. And according to Mr. CSEC, we have 8191 here. And then we have 81.91 here. Okay, now let's get to work. Let's read this program. All right. Monthly payment of 1,000. So it's 1,000 here. 1,000. The monthly payment is always going to be 1,000. Put the currency as well. All right. 10,000. Miss a zero here. Okay, let's get into this thing now, right? So the payment is always 1,000. Monthly interest. Hold on. Monthly interest is fairly simple. Monthly interest is 0.01. And let's speak to monthly interest. Hold a second here. It says monthly interest. Monthly interest is always 0.01, right? So is going to be, let me do it this way. This is equal principal interest is going to be equal principal multiplied by 0.01. 100. And then to get the new principal is going to be principal minus payment. Principal minus payment, which should be 9,000 here. All right. And then it's going to be equal to principal multiplied by 0.01. 90. All right. And then we subtract 1,000. There's something off with this. The month, let me look at this. Let me look back at this program here. A credit union gives loan of $10,000 at a fixed monthly interest rate of 1% on the principal amount. The monthly payment amount is fixed at $1,000. The payment paid to the principal each month is the monthly payment amount minus the interest paid for the month. Okay. All right. So I should not subtract 1,000 from this. It should be the amount minus the interest paid. So it should be 900. So the monthly interest is $1,000. So the new principal should be the $1,000 minus 100 and gives us 9,100. 9,900. Because we subtract 100, right? 9,900. 9,900. Yeah. All right. Let me check again. I want to make sure I'm interpreting this question correctly, because I'm not too good with this, what is interest and stuff. Yeah. The payment paid to the principal each month is the monthly payment minus the interest paid for the month. And the interest will be zero, so that's $100. All right. The pseudocode below will print a payment schedule showing the principal payment made to the principal and the interest charge for each month. Once the principal is greater than zero, the payment schedule will also print the total amount paid to the principal, the total amount interest paid, and the number of payments made. All right, cool. So then now, the next time is going to be, we get this amount by subtracting the what now? From 999 would subtract, let me do 900, and then we would subtract this minus 1,000 plus 999. 99, sorry. Minus 99. Sorry. Forgot my equal sign. I want to know that I'm interpreting this question correctly. 8801. I am missing something in this question. But there are a lot of questions here that leaves to be answered that I'm trying to work through. All right. A credit union gives loans of 10,000 at a fixed monthly interest rate of 1% on the principal. All right. The monthly payment is fixed at $1,000. The amount paid to the principal each month. So after the first month, 1,000. That's the interest paid, right? So subtract really. Let me go to the pseudocode. It's now 1% of the 1% on the principal. So 1% is 100. So you subtract 100 from the 1,000, you get $900. Hold on. Right? Oh, sorry. And those 100, yeah? Cool. 91. And let me go now, 91. Then now is 1% of the principal of this amount here. So it's 1% of this, equal this multiplied by 0.01, 91. Fine, fair enough, right? I will subtract this now. Subtract the 91 from the 1,000. Let's do it this way, right? Let's do this. This one's going to be equal to this minus this plus this bracket. That's what I get. And And the monthly interest is going to be, according to CSEC, I'm not getting the same answer. What am I doing wrong here? I'm now at 1 hour. Let me see this trace table here. 8191. I don't have 8191. Loop 1, loop 2, loop 3. I am not getting the same thing. Alright, let me take a little break on this. Okay guys, we're back again. Took me a little while to realize the error of my ways. Yeah, in too much of a hurry. Yeah, it took me a while to go down and just dig into it and work it through. My number one error. Mixing up monthly payment and payment. I had to go through and make sure I look at the code and decide what to write. Alright, so it took me about, to be honest guys, from I broke out start the meeting a while ago, as I was going at it for about 10 minutes, it took me an additional about 5 minutes also to look at the code and realize that I was making a simple mistake. Here's what the situation presents now. Remember this, the principal is 10,000, right? The payment is this. The 10,000 multiply, the 10,000 is the principal, but the payment is this. The payment here, payment, monthly payment minus interest. So the monthly payment is 1,000, right? So the 1,000 here minus the interest amount is the principal multiplied by the 1%, right? That's 900, and the principal multiplied by the 1% is 100. So this and this come to 1,000, which is a monthly payment. Same principle down here. However, the new principle would be this payment to the principal minus the old principal, right? Then we go over here. See something simple. I'm here killing me poor like a brain cells over it because me just trying to get a paper done in 1 hour. Yeah, not a good idea. But anyway, hopefully you are learning something other than just working on the paper. Don't do it in a hurry, work the time. All right, so we have 1,000 here, which is the payment, monthly payment. Are you going to subtract from that? The principal, the new principal is 9,100 multiplied by 1%. That will give us $909. 1% of the 9,100 here, 9,100, gives us $91 in interest, monthly interest. The same principle comes down here. We subtract the previous principal from the payment and we get the new principal of 8191. And then now, same routine. We have 1,000 minus the new principal multiplied by the 1%, and that we get 918. And this 1% now of 8191 gives us the amount that CSEC says of $81.91. Yeah. So much for trying to do in 1 hour. Now I'm 1 hour and 10 minutes. Stubborn, eh? Still trying to push the 1 hour thing. All right, but anyway, let's continue. Come back to this. I hope you guys realize that too. If you're stuck on a question for a little bit, sometimes it's not that you're not able to do it, but sometimes your mind is in a different gear. So continue, work through the questions, and then know when you're through, come back to it where you can spend some time and map it through. Because sometimes all that matters is that you can shift the gears a little bit and make your mind get sometimes settle down and read the question. All right? Identify two variables which, when added, will always be equal to the monthly payment of 1,000. Well, that is simple now because now we have a trace table. So the two payments that when added is payment plus monthly interest. Simple. All right. So we're done with that one, right? The pseudocode has a logic error. Identify the line with the error and make the necessary corrections. So here's the logic error here at line 14. We have right. It doesn't have to be a logic error, no. Because I was going to say we're having quotation marks, but then maybe they want the actual variable. So let's skip line 14 error. Set new principal to principal minus payment. Okay. Set count to count plus 1. Shouldn't be a problem. Oh yes. Why are we counting here? We don't need to increment. Are we asked to increment? No. We don't need to increment here. It's not like we're using count to determine how much time we're going to loop. I'm looking at line 14 here, line 12 here, guys. Set count to count plus 1. We don't need to be counting because count does not determine when the loop ends. The principal being greater than 0 is what determines when the loop ends. So count does not really matter here. All right. Right, principal. I don't see the logic error more than line 12. But then there's a rewrite it with the error, without the error, correct the error. So let's look for something that we can correct. While do set set principal, set payment, write principal payment interest. Set new principal to principal minus payment. Except though that this part new principal is where it is. We don't have anything in the code that says new principal. You should get rid of new principal here. It should be straight principal. We don't have principal anywhere in the code, new principal in the code. This is the error here. So line 11 should read this. Set, let me get rid of everything up top. Delete. Set principal to, I need this arrow. Let me see if I can get this arrow in symbols. Insert symbols. I know what, let me just shapes and just get this shape here. Alright, just use that shape and come back here. See what I'm doing. Principal minus payment. And then just continue. I say principal minus payment. Principal minus payment. So the error really in the code was about new principal. We don't have anything titled new principal. So that was our issue. So set principal to principal minus payment. That is the error in the code. And let me continue. What else do I have to do? That's 2 marks. Identify the stage in the program implementation where the type of error stated B will show up and state the consequence of the error. All right, it will show up in the compilation stage when you're executing it, and the consequence of the error is that we would get incorrect answers or printouts or solutions for the program. That is the consequence of the error. State the type of looping construct used in the pseudocode do while loop. Suggest one reason for why the looping construct in C is using pseudocode, because it's appropriate. It's appropriate because it's a while principal is greater than 0. So it's appropriate because you want to continue the loop when the condition is true. Right? So while the principal is greater than 0, continue to carry the calculation because the person has money to pay. All right? Explain one other name looping construct that could be used. Repeat until could also be used. And that ends our